We're going to look in this video at complementary relationships. Okay, so if you remember what complementary was, two angles were complementary if they added up to a 90 degrees, right? So let's think about this triangle here. Okay, and let's say this is theta. Let's say this is A, B, and C. What do we know? We know that sine theta is opposite over hypotenuse, right? So this is the side opposite to theta. Am I right? So that's going to be A over C, and A is your side opposite to theta. But now if you think about this angle here, well, if this is theta, this is 90, well, this angle is 90 minus theta, right? Because all of these have to add up to 180 degrees. So theta, if you just do a check here, theta plus 90 plus 90 minus theta, well, these two will cancel out, and that gives you 180 degrees, right? So this side, which was opposite to theta, well, it is adjacent to 90 minus theta, right? So we can think about this as adjacent to 90 minus theta divided by hypotenuse. And if it's adjacent over hypotenuse, well, that is nothing but the cosine of that angle. So this is cosine of 90 minus theta. Okay, now I forgot to mention this before, but just make a note here that when we are working with a right triangle, we typically give our angles in degrees and not in radians. Okay, but when you're working with a unit circle, we always work in radians. So please make that note. So sine of theta is nothing but cosine of 90 minus theta, and here's the work to show that, right? So we can have these relationships. I'm going to list out all the relationships here that are complementary relationships. Okay, so the first one, as we saw, is sine of theta is cosine of 90 degrees minus theta. Same way, cosine of theta is sine of 90 degrees minus theta, right? And then we have secant of theta, tangent of theta, right? Tangent of theta, so if I did tangent, that would be this over this, okay, which is going to be, for tangent, this is going to be opposite over adjacent, okay, and that would actually turn out to be adjacent of 90 minus theta over opposite of 90 minus theta. And so in this case, what we're going to get is this is cotangent of 90 minus theta. Okay, in a similar way, we're going to have cotangent theta is tangent of 90 minus theta. Secant theta is cosecant of 90 minus theta, and cosecant theta is secant 90 minus theta. Okay, so let's look at an example to see how this works. Okay, so let's look at the following example. So given the cotangent of 68 degrees equals 0.4040, find tan of 22 degrees, right? Now, 68 degrees is not one of your standard angles. So how do I solve this? If you notice, we notice that 90 minus 68 is 22 degrees, right? So these are complementary angles, and so here I know that cotangent of 68 degrees is equal to tangent of 90 minus 68 degrees, okay? And that is nothing but tangent of 22 degrees, and so tangent of 22 degrees is going to be 0.4040. Okay, so let's look at this example. We are cosine of 72 degrees is 0.3090, and we're going to find 18 sine of 18 degrees. If you look at it, 18 degrees is nothing but 90 minus 72 degrees, right? So again, they are complementary angles because 18 and 72 add to 90. So we know that cosine of 72 degrees, okay, is nothing but sine of 90 minus 72 degrees, and that is nothing but sine of 18 degrees. Now we know cosine of 72 is given to us. This is 0.3090. Okay, and so sine of 18 degrees is also going to be 0.3090.